Greetings, fellow nerds. I once again face my arch enemy, the Hotplate stirrer. This time, the stirrer part broke. And as you know, these things are too expensive to just throw away and replace, so I'm going to try and fix it. So first, the problem. When I turn on the stirrer, it does spin and it does work, but if you look at the speed counter, it's like it's 0. And the stirrer is actually spinning out of control. I can hear it getting louder and louder. This is a big problem since I do need speed control for slow stirring of viscous liquids. So let me unplug that and open it up. I think the sensor that measures the speed is broken. It thinks the hot plate isn't moving and so increases power to maximum to get going. I'll see if I can replace it. Most hot plate stirrers don't have any feedback and it's the user that adjusts the power to the control knob. The advantage is that such a system is simpler and cheaper and it will never fail from a bad sensor since it has none. The disadvantage is that you get less accurate speed control, but I'll be honest, as a chemist, I don't really care about precise or even accurate speed control. I just need it to be consistent. I think this is one of those parts that was over-engineered. Anyway, here we are inside, and it looks like the problem isn't exactly what I thought it was. This hot plate stirrer uses a disk encoder system to measure the speed. Over here is an optical sensor that measures a light beam across its gap. And on the motor is this disk with an array of slots that break the light path as it spins. As the sensor detects the pulses of light, it then converts that signal into speed. It looks like the sensor is fine, the disk is broken. And thus it's not breaking the light path and not detecting any signal. Looks like the teeth are broken, and when I shook the hot plate stirrer they fell out. So this is not good. I was hoping for the sensor to be broken because that's a mass-produced part and easy to find and replace. The disc is a lot harder since they often are custom-made or not sold separately from the motor they are made for. It's just not expected for the disc to break. To replace the disc, we'll have to 3D print or laser cut a new one. To jerry-rig a repair, I'm simply going to glue the encoder disc back into place. I'm using silicone rubber, so it shouldn't be too hard for me to peel it off again in the future should I need to. I don't need to exactly replace the teeth on the encoder disc because I don't need accurate speed control, just consistent speed control. The missing teeth will create less signal for the sensor circuit, so it will spin faster to compensate. So while the display may read 100 RPM, it'll actually be running faster at say 150 RPM. As said before, I don't need accurate speed control, so the issue is acceptable to me. There are still enough teeth left over that I don't think it'll be too much different from before. Okay, I'm going to leave that in for a couple of days to dry. And here we are, let me reassemble that. And it looks like it spins freely. I was worried the glue might change the clearances too much and cause the parts to start hitting each other. Okay, let me reassemble the unit and test it. And there we go, it's reading its speed as it should, but we know it's wrong as some teeth are missing. Nonetheless, it works, I just have to use lower speed numbers. Let me test it with a beaker of water, and it looks like it's working fine. I've regained speed control for this hot plate stirrer. I can now put this hot plate stirrer back into service. So that was me repairing my hot plate stirrer. I was wondering, was this video worthwhile to watch? All I did was glue back one part. But was the explanation of how it worked and why the broken teeth don't matter informative? Let me know in the comments. I'm wondering if I should keep producing simple lab equipment videos. Thanks for watching. Special thank you to all of my supporters on Patreon for making these science videos possible with their donations and their direction. If you're not currently a patron but would like to support the continued production of science videos like this one, then check out my Patreon page here or in the video description. I really appreciate any and all support.